Accelerate the speed of simulation studies with automated processes that validate design performance. Solid Edge simulation capabilities provide design engineers with powerful tools to help digitally validate their designs and build better products in less time by front-loading the simulation process. Solid Edge simulation can calculate hydrostatic pressure loads in a linear static or coupled study. This can be used to determine the maximum and minimum pressure that is exerted by a fluid from a given point due to gravity. Running such a study on this tank for a dosing assembly line, we simply need to select the faces the load will be applied to, define a height for the fluid in the tank, and define the material density. In this case, we'll also apply a fixed boundary condition to the bottom of the tank, then mesh and solve the simulation. Here we have a new body mesh option, a new Siemens mesh technology that simplifies and improves the tetrahedral mesh for complex parts with intricate bodies and automatically cleans up small faces and edges. Viewing the results, we can see the areas of higher stress at the bottom of the tank and lower stress at the top. The maximum stress value is nowhere near the yield stress, so the thickness of our tank is more than adequate for the job. Adjusting the level of the material in the tank is as simple as editing the hydrostatic pressure load and selecting a new reference point, or simply adjusting the offset value. Solving the study again allows us to see the differences in pressure that the lower fluid level has on the tank. Next, we'll look at some of the enhancements to simulation studies of structural frame models. As we define this study, we can see that automatic link creation now considers all cases where rigid links need to be created and only creates those needed for the study. We can adjust the connector option to specify a maximum rigid link length to automatically create links, or, as we'll do here, we can use the automatic link command, which enables the model to be set up far more quickly. We'll go ahead and apply a fixed constraint to the bottom of the structural frame and define a force to the top two horizontal beams, then solve the study to see the results. Another new feature for Solid Edge simulation is the ability to view beam von Mises stress plots for frame models. Factor of safety plots have been enhanced and are now based on the von Mises stress, producing far more accurate results than the maximum combined stress results that were used previously. Switching back to the main assembly, we can see there are some pins holding the dosing mechanism in place. Opening one reveals that it's a mesh body. Solid Edge simulation can now validate mesh models resulting from a 3D scan or generative study. Here we can see the results of an existing linear static study. Being able to create the simulation mesh right on top of an existing mesh body truly sets Solid Edge apart. There's no reverse engineering or any other complex procedure required. Simulation-driven design helps designers get immediate feedback on design performance by embedding simulation into the CAD environment and designers' processes. Simulation display performance optimizes load times for results data, making Solid Edge simulation faster than ever before.